This is part 4 of section 3.4. We want to find all of the zeros of this polynomial function. It's set equal to 0, but you can think of this as f of x. First, let's deal with the Descartes' rule of signs and count. Well, first of all, I know I should have 4 solutions here, so that's a degree higher than what we've been dealing with so far. That does add a level of complexity, but it's not that much harder. Let's go ahead and count how many sign changes we have here in order to find out the number of potential positive solutions. So that's a positive to a negative, so that's 1. To positive, that's 2. To negative, that's 3. And then negative. So I have 3 or 1 positive real solutions. Now let's find f of negative x, which means changing the sign on everything with an odd exponent on it. And what I often do, just because I don't like recopying things all the time, that's a place to make a stupid mistake. What I often do is I just change the signs above it. So this would stay a positive, that would go to positive, this stays a positive, this one would become a positive, and then that one's negative. So positive, 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 positive to negative. That's 1 sign change. So I have 1 negative real solution. Okay. Now my p-values come from -8. So all of my p-values are things that divide evenly into 8, which of course is, don't forget your plus and minus, 1, 2, 4, and 8. And my q values come from the coefficient of x to the 4th, which is a 1, so q is only plus and minus 1. Now, since to find p over q, I would put all of these over 1. In this case, this is also our p over q list, because we're dividing all of these by 1. Okay? So let's jump in, pick something to try. Let's try a 1. Write down all of your coefficients here. That's 1, -1, 2, -4, and -8. Bring down the 1. Multiply, and you get a 1. Add to 0. Multiply, that's a 0. Add 2. Multiply, that's 2. Now add, that's a -2. So since I have a different sign here, I know this is not an upper bound. -2 times 1 is -2, and that does not give me a 0 there. So -1 did not work. Okay, so let's try 2. I use 1, -1, 2, -4, and -8. Bring down the 1, multiply, that's a 2, add, that's a 1, multiply, that's a 2, add for 4, multiply 8, add, that's a 4, multiply, and that's an 8, and you get a 0. So this tells me 2 things. First of all, one of my solutions is a 2. So I know that. But if you look here, I also ended up with all positive numbers here. 0 can either be considered a positive or a negative for as far as this goes. So that tells me that 2 is an upper bound. I do not have a positive solution larger than 2. Okay? So this also eliminates 4 and 8. Okay? So what I have now is I have a new equation to solve. I have one of my solutions, and now this makes it easier. Okay? This started off with a 4. This is the same as x cubed, 1x cubed, plus x squared, plus 4x, plus 4. And now, since I have one of my solutions, if I solve this, that will give me the rest of my solutions. Okay? Now you can start all over again. You may not want to use this original P over Q list because it may be that, of course, we used the theorem to eliminate 4 and 8, but it's also possible, if you just look at this, your p-values would come from 4, which means 8 could not be a solution anyway. Let's use this again, and again look at how many sign changes we have. So if I'm using this one now, it's basically like a new problem. How many possible positive solutions would I have? I have no sign changes. So I have no more positive solutions. And that also bears out because I checked 1, it did not work. I checked 2 and it did work, but 4 and 8 we already knew did not. Okay? Now let's look for the number of negative solutions. Let's just think about what our signs would be. This would be negative and positive and negative and positive again. So how many sign changes is that? That would be 1, 2, 3 sign changes, which would be 3 or 1. Well, we already knew overall we can only have one solution. So even though we have this, we know we have one negative solution, okay? And we know that our p-value is going to come from 4. Not 3, and plus or minus 4. Sorry, I don't know why I wrote down 3, just in a habit, in a groove. And then of course our q value comes from 1. So this is our p over q. So my possibles are 1, 2, 4, negative 1, negative 2, negative 4. Now I know that I've already checked all my possible positive solutions, so I'm just going to jump to a negative and see what I get. So let's just try negative 1. Now I don't want to come back and use these same values up here, because if I do that, then I'm not going to catch any double roots. I want to use these coefficients, or the coefficients of this equation from now on. So I have 1, 1, 4, and 4. Bring down the 1, multiply, that's a negative 1, which gives me a 0. 0 times negative 1 is 0. Add, and you get a 4. Multiply, and you get negative 4. And add, you get a 0. So that means negative 1 is another solution. Now I needed to do this because once I found one solution here, it only brought it down to a cubic equation. And I only know how to solve, in general, a quadratic. So only if I have a square. Now here I have 2 of my solutions. I have 2 and I have negative 1. Now to get my other 2 solutions, because I expect 4, I now need to solve 1x squared plus 0x plus 4. So I need to solve x squared plus 4 equal to 0. Now I can easily make this into a square root property problem by getting the square by itself. So I'm going to subtract 4 from both sides. And I get x squared equals negative 4. Now I'll take the square root of both sides. And you get x is equal to, when you take the square root over here, you need a plus or minus. And then the square root of a negative number is going to have an I in it. The square root of 4 is 2, so this is plus or minus 2i. Now what we learned earlier is if you have a complex solution, you will always have 2. One with a plus, one with a minus. So your 4 solutions here are 2, negative 1, negative 2i, and positive 2i. Descartes' rule of signs only gives you the number of possible real solutions, so it did not include these 2. I knew I'd either have 3 or 1 positive solutions. I have 1. I knew I would have 1 negative real solution. I have one of those. Okay, so this is our overall solution.